Hello there, welcome to my channel on chemistry lessons. This is AQA A-level chemistry and it's looking at amino acids. So this is what the specification wants us to do. So by the end of this video then we need to know the structure of amino acid and to be able to draw those structures in terms of Zwitter ions or what they'd look like in acidic conditions or in alkaline conditions. First up though, you know what to do. If you don't subscribe, please do. Your support is very much appreciated. Thank you very much. So let's look at the structure of a general amino acid. The clue's kind of in the name. It's a molecule that contains an amine group and an acid group. Hence the term amino, you got it, and acid. So we have an amine group and a carboxylic acid group attached to the same carbon. And to finish this molecule off, we have a H, and then we have, I'm just going to call it an R group because this is what makes different amino acids different. So every amino acid that we look at will have an amine group and a carboxylic acid group on the same carbon. There'll be a H on this carbon, there it is, and there'll be what we call another side chain. Now this R group can be many different things. It could be a CH3 group, for example, or it could be whatever. Okay, that's what makes amino acids different. And if we look in our data book, we can see that they give us 6 examples. Now there are more than 6 different amino acids, but these are the 6 amino acids that are given in your data book. So you don't need to know these, they're given. In fact, you don't need to know any amino acids. What I'm going to point out here though, is in some cases, the side chain, so look here, there's our CH, acid, amine. So our R group on alanine, the R group is in fact CH3. Now the R group, as you can see looking at the other 5, can contain all sorts of other side chains. And lysine, for example, the side chain contains another amine group. So there's actually 2 amine groups in this amino acid. And if we look at aspartic acid, the side chain contains a carboxylic acid group, which means that aspartic acid has 2 carboxylic acid groups. Okay, so let's remind ourselves of what we learnt about when we did carboxylic acid. So you'll have already studied carboxylic acids by this point, and you'll have studied amines by this point in the spec. So let's just have a look at what we mean by the fact that amino acids have both acidic and basic properties. Well, what did you learn about carboxylic acids? Well, the first thing you should have learned about carboxylic acids is that they are in fact weak organic acids, which means they can donate protons. So this proton here can be donated. And this can become O-. So that proton can be donated, so it can act as an acid. We also have an amine group, and what you learnt about amines that they can act as bases. There's a lone pair on that nitrogen that can accept a proton. So the amine group will quite happily become NH3+. So that's showing how it can act as a base. So it can act as an acid and a base because it has the acid group that can donate a proton, weak acid, and it also has the NH2 group that can accept a proton. Simples. Okay, so let's get on with this next term then. It says including the formation of Zwitter ions. In my head that's German, I don't know, maybe it is, maybe it isn't, but I've made this up. So please don't sue me if it's wrong. But I know the German for 2 is Zwei, and this makes sense. The Zwitter ion. Let's see if that's true. Anyway, what is a Zwitter ion? So let's do an amino acid. Just any standard amino acid. Now, the Zwitter ion is when it exists as both the positive and negative ion. In other words, the proton in the acid has been donated to the amino group. So that is the Zwitter ion. And this is true for all amino acids. I don't care what this R group is. That is showing the formation of the Zwitter ion. you're welcome. Okay, the final thing then is we need to look at the structure of amino acids at high pH and low pH. So everyone say hi to pH. Say hi pH. Hi. Okay, just a bit of banter. So high pH means, what does that mean? Well, a high pH means alkaline conditions, which basically means, didn't even mean that. Basically means there's lots of OH minus ions. In other words, any acid groups will donate protons. So what we're going to do, what will alanine, I can't even say it, alanine look like in a high pH? Well, this H plus would have been donated and there'll be a negative sign here. So it's COO minus. Always check your side chain, because if there's an acid group in the side chain, that too will donate a proton. Be careful. Check your side chains weekly. Right, one underneath, lysine, again, autopilot. The acid group will donate a proton, so the H plus is gone, leaving behind the minus. Don't forget to check your side chains. No acid in the side chain. Let's go to aspartic acid. Right, well, the carboxylic acid in the amino group, in the amino acid, sorry. What am I talking about? Amino group. So this will donate a proton. Remember, check your side chains. Woo, 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 woo. There's an acid in this side chain, so both acid groups donate the proton. Let's have a look at the cysteine chapel over here. Get rid of this. There we go. Phenylalanine. Get rid of that. Minus. There we go. Checking the side chains as I'm going, but I'm on autopilot. There we go. So that would be the structure of those 6 amino acids at a high pH. Any acid groups will donate a proton. Simple as that. Okay, it's time for the low pH. The low pH. Just a joke. So this time low pH means acidic conditions. That means lots of H plus ions are present. So that means any amine groups will accept a proton and become positively charged. So here we go. Alanine, this H2, this NH2 group here becomes NH3 with a positive charge on the nitrogen. And remember to check your side chains. So next one, lysine, this becomes NH3 plus. Oh, side chains, got an amine group in. There we go. So that'll become NH3 plus. Aspartic acid, NH3 plus. Cysteine, NH3 plus. Serine, NH3 plus. I am checking the side chains as well. I'm just that good at it that I'm not telling you. This one as well, NH3 plus. Job done. You're welcome. All finished. We've done amino acids. Give yourself a round of applause. And there we go. That has it. Thanks for watching. You know the drill. See you next time.